here we go.
Okay.
All right, so this is what we've done now. We have still the same board. Now we have changed the J3 header for 50 hertz as opposed to 60 hertz. We have left the adjustment of the span and the bias just as we did on the first video, and of course now we're bringing in our 50 hertz supply, and we can see that the frequency now it's 50 hertz. If we just plug in our board without making adjustment to the span and bias, we notice that the board is going out of lock. There's no synchronized firing, or there's no synchronization between the delay angle and TP7, the phase reference, TP8 to TP7. So what we're going to do is, what has to be done on the field is, we're going to bring those two span and bias at 100%. We're going to start from 0. Although the boards were adjusted for 60 hertz here in the US, we're going to bring them back to 50. And we're going to do this all over again. So go ahead, Tony. You want to go ahead? So you notice that now the board it's at 0. It's on lock, and Tony's going to go through the same procedure. He's going to increase SIG high just until he clears that. There you go. Now he's cleared the delay angle, and this is what's going to happen if the board is not properly done. He just went to SIG high where he clears that red LED, but you notice that the output, it's not that tiny pulse. Now we have an output. So what Tony's going to do is he's going to reduce that, and again he is going to reduce it until he just has a little spike where the duty cycle of this it's minimum. Now in this particular case at 50 hertz, the bias it's at approximately 75-80%, and again that will be determined by that signal, when that signal is minimum. If this is not minimum, then you're going to get a jump. Alright, so now we're going to go all the way to 5 volts. We notice that duty cycle of TP8 is decreased, and then now he's going to use the span just until when he starts that this is maximum, and then he starts reducing this SIG high to 5 volts. This will follow with it, so there's a linear response. Is that there, Tony?
Mm-hmm.
In this particular case, it also stay at about 100, right?
Yep.
Okay, and so this is at 5. Go ahead, Tony, and start reducing. So he starts reducing it, and then it's fine. Bring it back to 5, please, Tony. Now, for illustration purposes, let's incorrectly set this to 50%, the span. This is an incorrect way to do it. Well, we notice there that although our SIG high is at maximum, the 5.2 volts, this is not the maximum. So at this point, the span is incorrectly set. So go ahead and adjust it again, Tony, so that you have the maximum output. And when you start decreasing that SIG high from 5.2, that width of that output starts immediately decreasing. Now, with this, if Tony's going to go to 0, see, at 0, when SIG high is 0, and the board is on and it's inhibited, we notice that the board it's out of lock. But that's okay, because at this point the board's inhibited. Now let's see what happens, and go slowly, please. And just stop when you clear that red LED. Right about there, you have 0.6, which is just above that diode drop. And you notice that now the board has corrected itself, and because the board is properly adjusted, we have that single impulse, and that's not going to cause a jump in voltage and current. Am I missing anything there, Tony?
No, that's fine.
And
that's
this is the end of the video at 50 hertz, and this is what has to be done in the core in the Middle East to prevent this issue with these 3 boards.